Have you ever wondered if the sun's activity could be influencing our climate? It's a question that's been at the heart of some fascinating scientific investigations for years now. The answer lies in something we call solar cycles, a regular rhythm of solar activity that unfolds approximately every 11 years. The sun, it turns out, has its own heartbeat. So, what exactly are solar cycles? Well, they're essentially fluctuations in the sun's magnetic field and activity. These cycles manifest through variations in solar irradiance, sunspot activity, and other solar phenomena. Now, here's where things get interesting. Over the years, researchers have noticed certain patterns. Periods of increased solar activity, marked by higher sunspot numbers and solar irradiance, often coincide with warmer temperatures on Earth. On the flip side, when the sun's activity takes a dip, Earth tends to cool down a bit. But the connection between the sun and Earth's climate isn't as straightforward as it might seem. You see, our planet's climate system is a bit like a massive, intricate puzzle, with pieces ranging from greenhouse gas concentrations and atmospheric dynamics to oceanic currents and changes in the land surface. While solar irradiance undoubtedly plays a role in this puzzle, it's just one piece of the bigger picture. Then there's the question of how solar activity influences our climate. Some effects are direct, like changes in the amount of energy hitting our atmosphere. But there may be other, less obvious pathways at play too. For instance, shifts in ultraviolet radiation and solar wind activity can impact the composition and dynamics of the upper atmosphere. These changes can potentially influence atmospheric circulation patterns and regional climates. In recent years, we've made some exciting strides in understanding the relationship between solar activity and climate. Sophisticated computer models now allow us to simulate past climate variations and project future scenarios. But there's still a lot we don't know. The historical record of solar activity and climate change is filled with complexities and uncertainties, and we're still working to untangle them. Let's delve deeper into the mysteries of these solar cycles and their relationship with our planet's weather patterns. After all, every piece of the puzzle brings us one step closer to comprehending the grand tapestry of our climate. Solar cycles are not just about the sun getting brighter and dimmer. This statement may seem surprising, but it's the essence of the intricacies that lie beneath the surface of solar cycles. Solar cycles, at their core, are characterized by fluctuations in the sun's magnetic field and activity. This dance of magnetic forces occurs in roughly 11-year cycles, aptly named the solar cycle. These cycles tell a story of the sun's temperament, manifesting themselves through variations in solar irradiance, which is the sun's radiant power, and sunspot activity, those dark spots that freckle the sun's surface. Historically, researchers have observed intriguing correlations between these cycles and certain climatic patterns on Earth. Picture this: periods of increased solar activity, marked by a flurry of sunspots and a surge in solar irradiance, have often coincided with Earth donning its warmest attire. On the flip side, during times of decreased solar activity, such as during solar minimums, Earth has sometimes slipped into its cooler ensemble. But it's important to remember that correlation is not causation. While these patterns are fascinating, they don't necessarily imply that solar cycles directly cause these climatic shifts. After all, the Earth's climate system is a complex orchestra, with numerous instruments playing their parts. Greenhouse gas concentrations, atmospheric dynamics, oceanic currents, and land surface changes all contribute to the symphony of our planet's climate. So, as we delve into the intricate ballet of solar cycles, we're left with a burning question. Despite the observed correlations, despite the fascinating patterns, is there a direct causal relationship between these cycles and climate change? This question is what drives scientists to probe deeper, to research further, and to continually strive to unravel the mysteries of our sun and its impact on our home planet. But the question remains, is there a direct causal relationship between these cycles and climate change? As we move forward, we'll continue to explore this question, delving into the complexities of climate change and the mechanisms that may link it to the intricate dance of solar cycles. Unraveling the influences on our climate is like solving a complex jigsaw puzzle. Each piece represents a different factor impacting our planet's climate. Solar irradiance is one such piece, but it's just a part of the wider climate jigsaw. Our Earth's climate system is a vast, intricate tapestry woven from various threads of influence. It's not just about the sun and our distance from it. It's also about the concentration of greenhouse gases in our atmosphere, the dynamics of the air above us, the swirling currents of our oceans, and the changes on the land surface beneath our feet. Every one of these elements has a role to play, and they all interact in ways that can amplify or dampen the effects of the others. Within this grand tapestry, solar irradiance undoubtedly has a role. It's the energy that drives our climate, that fuels the processes which make our Earth habitable. But it's important to remember that solar irradiance is not acting in isolation. It's a player on a stage filled with other actors, all performing a complex, interconnected dance. The dance becomes even more intricate when we consider that the mechanisms through which solar activity influences our climate are not fully understood. We know that changes in solar irradiance can alter the amount of energy reaching our atmosphere, but that's not the whole story. There may be other, more indirect pathways at work as well. Changes in ultraviolet radiation and solar wind activity, for instance, may impact the composition and dynamics of our upper atmosphere, potentially influencing atmospheric circulation patterns and regional climates. Furthermore, the historical record of solar activity and climate change is filled with complexities and uncertainties. While some studies suggest strong correlations between solar cycles and certain climatic patterns, others find conflicting evidence or highlight the importance of regional variability and feedback mechanisms. The relatively short span of reliable observational data adds another layer of complexity, making it challenging to discern long-term trends and distinguish between natural climatic variability and human influences. Understanding how solar activity influences our climate is a challenging endeavor, but it's a puzzle we're determined to solve. As we continue to dig deeper, to ask more questions, to gather more data, we get closer to completing the picture, to understanding the intricate dance of our climate. Solar activity's influence on climate isn't just about the amount of sunlight we receive. It's a common misconception, but the truth is, the mechanisms at play are far more intricate and multifaceted. Let's dive in to understand how this celestial dance between the sun and our planet goes beyond mere sunlight. Imagine the sun as a colossal dynamo, sending out more than just light. It releases a spectrum of radiation, including ultraviolet light, along with a stream of charged particles known as the solar wind. These aspects of solar activity, while less visible to the naked eye, can have significant effects on Earth's climate. Take ultraviolet radiation, for instance. This form of light is more energetic than the visible light we see, and it interacts with our planet in unique ways. When ultraviolet radiation levels increase, they heat up the stratosphere, the layer of the atmosphere above where we live. This heating can cause a ripple effect, altering wind and weather patterns even down at ground level, potentially shifting climates in certain regions. Now, let's consider solar wind. This is a stream of charged particles that the sun continuously ejects into space. When solar wind activity intensifies, it can interact with Earth's magnetic field, affecting the composition and dynamics of the upper atmosphere. This, in turn, may influence atmospheric circulation patterns and regional climates. But here's the catch. While these mechanisms are scientifically plausible, proving them conclusively is still a work in progress. The Earth's climate system is incredibly complex, and isolating the effects of solar activity from other influential factors is a challenging task. Moreover, the sun's activity itself is not constant. Solar cycles, with their ebbs and flows of activity, add another layer of complexity to this puzzle. Our understanding of these cycles and their links to climate change is constantly evolving, fueled by ongoing research and advancements in technology. So, while we have some tantalizing hints and potential pathways, it's important to remember the ways in which solar activity can impact our climate are complex and not yet fully understood. Our journey to unravel these mysteries continues as we strive to better comprehend this cosmic ballet between the sun and Earth's climate. Studying the past can help us make sense of the present and predict the future. As we delve into the historical record of solar activity and climate change, we encounter a labyrinth of complexities and uncertainties. There are studies that suggest strong correlations between solar cycles and certain climatic patterns. Yet, others present conflicting evidence or highlight the importance of regional variability and feedback mechanisms. The relatively short span of reliable observational data adds another layer of challenge, making it difficult to discern long-term trends and separate natural climatic variability from the effects of human activity. However, the past few decades have seen significant advances in climate modeling and observational techniques. Scientists have been able to gain deeper insights into the intricate dance between solar activity and climate dynamics. Sophisticated computer models now incorporate complex interactions between the sun, atmosphere, oceans, and the biosphere. These models enable researchers to recreate past climate variations and project future scenarios under different solar forcing conditions. These models, while impressive, are not perfect. They still carry uncertainties, especially when it comes to capturing the subtle nuances of solar influences on climate. But they're continually improving, and with each refinement, we get a little closer to understanding the complex relationship between solar cycles and Earth's climate. The future of this research is ripe with potential. The increasing precision of observational data, coupled with ever-evolving computational capabilities, will allow for even more accurate models. These advancements will not only enhance our understanding of past climate variations, but also improve the accuracy of climate predictions. As we continue to probe the mysteries of solar cycles and climate change, we inch closer to understanding our place in this vast universe. We learn that we are not merely passive observers in this cosmic dance, but active participants, whose actions can have far-reaching implications for our planet and its delicate balance. As we continue to probe the mysteries of solar cycles and climate change, we inch closer to understanding our place in this vast universe.